Hello, students. We are jumping into 13.4 homework. So we've got 2 to 3, 5 to 10, 12 to 14, and 19. So not a ton of questions. Again, basically, we're just practicing these formulas. So if I were you, what I'd recommend is have your formulas right near you on a page, and then just go through and practice. What are the formulas we're looking for? The formulas we're looking for are the prism slash cylinder, because these are the same. That's 2 area of the base plus the perimeter times the height. Okay, there we go. Then we've got pyramid, and the pyramid goes with the cone, and that's 1 base plus half the perimeter times the slant height. And then we have the sphere, and the sphere was 4 pi r squared. Now, I recommend having those out and ready to go. So let's jump in here and see how we do on the homework. So we got 2 to 3. So again, here's 1. This is a pyramid. So what do? I jump over to the pyramid shape. It tells me everything I need to know about the shape. Let me grab a little bit of white space here. So I'm not going to go through all of these, but I think if you need to, you can also do the additional ones in part A. But it tells you that it's a square. So for this square, they tell you the length of one side right here. Got it. 5 centimeters on a square. It is a pyramid, so I need the area of the base. The area of the base is 5 times 5. That's 25 square centimeters. Now I need half the perimeter times the length. Well, the perimeter would be 4 times 5. That's 20. Half of 20 is 10. So it's 10 times the slant height, which would be 65 square centimeters. Okay, so if you want to go a little bit slower, 5 squared, 1/2 times 4 times 5, that's the perimeter, and times 6.5. That's how I got those pieces. And then just add them together, because 20 plus 60 is 80, plus 10 is 90. So I get 90 square centimeters. And that would be the surface area of that shape. All right. I'm going to try to leave my formulas up there, so I'll just erase manually. We'll see how that goes. Okay, so there we go. Now, I'm not going to do all of them, of course. That's not the point of homework video. Right circular cylinder, topped with a hemisphere. So pause. I need surface area. So surface area, you're going to think cylinder right off the bat, because we know we have one for the cylinder. But realize it's been topped with a hemisphere. That's half of a sphere. So I don't need 2 bases now, because 1 base is going to have a hemisphere on top of it. So that's what is on the surface. So I need a base plus the perimeter times the height. That takes care of the base on the bottom and the lateral surface area. And then I need plus half of a sphere. Well, a sphere is 4 pi r squared, so I need 2 pi r squared. And that would be kind of the setup here, and very similar to the one in number 2 right next to it. Okay, let's move on down to number 3. How many liters of paint must you buy to paint walls this, da, 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 da. And it says 1 liter of paint covers 20 square meters. So you need to find how many total square meters you have, and then you convert. This goes back to unit conversions in 13.1. So find how many square meters you have. So find the area, in this case, the surface area in square meters. And then use this as your unit, because what they're telling you is that 20 square meters is the same as 1 liter, right? So how many liters of paint do you need to buy? You'd multiply, the square meters go away. You're left with how many liters? Now, if I was asking this question, I would probably change it just a little bit, and I would say, how much would it cost? And I would tell you how much a liter of paint costs. And the reason for that is, if you end up with 3.72 liters, understand that you need to buy 4 liters of paint. Okay. If you end up with 2.14 liters, guess what? You need to buy 3 liters. You can't round that down. You won't have enough paint to make it. So yeah, that's probably the one tweak that I would make to this type of problem, is just to say, yes, it's about finding how many total liters, but I think you can also find a little bit more than that. Okay, so let's see here. There's 3 to 4, or 2 to 3, then 5 to 10. Okay, so 5 through 10. What happens to the surface area of a sphere if the radius is doubled or tripled? Grab your formula for the sphere, put in a radius. You can do it with numbers and kind of see it. If you want to kind of push yourself a little bit, put in 2r for the radius in parentheses and then square it. Put in 3r for tripling, and then you can compare it back to the original form. Okay. How does a surface area of a right rectangular box? Right rectangular box. Hey, that's a prism. How does it change if each dimension is doubled, tripled, or multiplied by a factor of k? Again, same concept. Plug them in. My recommendation is go back to your dimensions that you would have had, plug in 2 times that dimension and replace them all and see what you get at the end. Okay. Approximately how much material is needed to make the tent here? Now there was an issue that some students do have. It's that they look at this and they oftentimes think the base is this rectangular component. But we can look at this shape and say, wait a minute, that is a prism because there's the same shape on 2 sides, the exact same shape. And those would be your bases. Your base would be the triangle. So what you need to find for this one is, if you want to find surface area, you need to find 2 times the base plus perimeter times height. And along the way, you'll notice they did not give you this length right here. I will tell you that you can assume that this is a right angle at the bottom. I wish they would have put that in there. They did not, but I'm going to tell you to please assume that. You know the base over here is 5. Find this length. Hint. Pythagorean theorem. And again, that'll be the exact same as the one over there. Let's see here. What else do we have? Now they say approximately how much, and the reason for that is when you have a triangle like this, the length here will be an irrational number. It'll be a square root of something. So that's why they phrase it that way. Let's see here. A square piece of paper, 10 centimeters on a side, is rolled to form the lateral surface area of a right circular cylinder. Then someone adds the top and the bottom. What is the surface area of the cylinder? Right? Well, that's kind of cool. I kind of like that idea. Makes you think a little bit. So you are going to end with a shape that kind of looks like this. They're just telling you that this lateral surface area right here, all of that is coming from a piece of paper like this. And they just rolled this end and rolled it around to get onto that one. That's how they rolled it up. So look at your formula. You want surface area of a cylinder. Cylinder right here. 2 times the base plus the perimeter times the height. Well, you know the perimeter, right? And you know the height because you rolled it from a square. So again, when we say perimeter, it's the perimeter of the base, which is that circle. And then you need 2 times the area of the base. And the base, again, is going to be this circle piece here. So if you're struggling at all, you do know the circumference. The circumference is 2 pi r. And in this case, you know exactly what it is because you used it from that piece of paper. All right, there we go. Next up, I think we have number 9. Structures composed of unit cubes with at least one face on each cube showing, and at least one connected to the face of another cube as shown in the following diagram. I bet you're going to find the surface area. Let's see here. If 1 cube is added, what's the maximum surface area the structure can have? Oh, good one. If 1 cube is added, what's the minimum surface area the structure can have? Is it possible to design a structure so that you can add a cube and yet add nothing to the surface area of the structure? So I want you to think about that in this situation and see if you can kind of think of, hey, how could this actually work? So first, find the surface area of the shape here. Maybe I'll do that part kind of with you. So when I do these surface area pieces, I like thinking of it as like viewing it. Okay. So if I view it from this direction from the front, I will only see these pieces. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8. But I'd also see the exact same pieces looking from the back side. So I have 2 times 8. Now let's look from a different direction, right? Now let's look from, where do we want to look from now? I don't know. It would look from the top. Okay, so looking from the top, I would see this, right? I'd see this one over here, looking for all the tops, and there would be a top in here as well. Okay, so that's 1, 2, 3, 4, 5, 6. Now, when I look from the bottom, I'd see the bottom of this one, then the bottom of the 3 next to it. So 3, 4, right? 5 over here, and 6 looking up and seeing the 1 in here. So that's definitely 2 times 6. And lastly, if I look from the left and the right, oops, wrong one. Then I would see this 1, 2, 3, 4, 5, and I'd see the one inside here, which is 6. So I'd get 2 times 6 again. So 16 plus 2 times 6 is 12, plus 12 is 24. So this looks like right now it has a 40 units is the surface area. So again, now you have to, when you put your next cube on, you have to have it touching, sharing a side, sharing a face with at least one other cube. So when you do that, I mean, you could think of adding a cube like down here to the front. Okay. You could think of adding a cube over here next to this one, right? But again, once you do, determine what your new surface area would be and think about where it's minimized and maximized. Let's see here. Ooh, through 10 and then 12 to 14. Let's see here. So 10 is, how does the lateral surface area change if the radius is doubled and the height? Okay, so this is a cylinder. So here's a cylinder. What happens when we do things to the sides? You notice I've now given you one of those for a sphere, for a prism, and for a cylinder. Nudge, nudge, wink, wink. There's a reason why I assigned all of those. Okay, next up, number 12. So what we have is region of each of the following. A three-dimensional figure obtained. Sketch the figure and name and sketch the figure and find the surface area of each. So when you spin this one around, take a look at what you're going to get. So when you spin this, again, each one of these is going to rotate. Each one of these here is going to rotate. Each one of these here is going to rotate. And the last one over here is going to rotate. And so what you end up with is a cone. And because it goes straight down the middle, a right circular cone. And once you have that right circular cone, you can determine everything you need for the cone formula. Notice in the cone formula, you do need the slant height. The slant height would be this component right there. If you spin this one around, you'll kind of make a little circle here, circles all the way down. And so this, because there's circles all the way down, is a cylinder, and again, is everything you need. Part C, number 12, is a challenging one, but I'm going to tell you what you can do. I'm going to give you a huge hint right here. Huge hint. Extend this down. Extend it down so that now you have similar triangles for one. So you can find the different sizes that you need. And then you could also say, I could find the total area of this big cone and remove the component of that, which is right here at the beginning for the small cone. So my hint is big minus small. All right, so that takes care of 12. Let's see here, what else? We have things 12 through 14. A right square pyramid, a right circular cone are inscribed. Find the surface area of the pyramid and the surface area of the cone. Perfect. So they're inside of a cube. So it is a cube. So now I have the overall height. I have the width. I don't have the slant height, but Pythagorean theorem. And I think that's it. That is everything you need for both pyramid and cone. Now do remember, because this is a right square pyramid, that it would go all the way. It kind of shows that, but it's maybe a little bit hard to see. It goes all the way to the outside edge of this. So the base, the pyramid is the one that's I'm sorry, the cone is the one that's shaded. The pyramid's base would actually go all the way across that entire square. And so it does look a little strange, perhaps, because they're trying to show three things in one. But that's what they're trying to do there. Okay. And 14, a gas storage tank in the height of a right circular cylinder has a radius of this and a height of this. Farmer wants to paint the tank and only has 1 gallon of paint. The gallon of paint will cover 350 square feet. Does he have enough paint? So again, very good idea here. Find the, yeah, wants to, in the shape of a right circular cylinder. So it is a cylinder. So there's our formula. We have everything we need because it gave me the radius and it gave me the height. And yeah, we're good. Very cool. Very cool in 14. Oh, 19 is the last question I had. The figure shown here, a right circular cylinder is inscribed. Find the lateral surface area of the cylinder. The height of the cone is 40. The height of the cylinder is 30. The radius of the base of the cone is 25. Put in what you know, just like in all of the problems that we have. So the height of the cone, which is here, is 40. The height of the cylinder is 30 centimeters. And the radius of the base of the cone is 25 centimeters. Now, this looks like it's going to be a little challenging because it says you're trying to find the lateral surface area of the cylinder. So in order to do the cylinder, what do we need? I need the area of the base, I need the perimeter, and I need the height. Well, we have the height, so that's one of them. You need the rest. My strong, encouraging hint is to think of similar triangles. And let's see if I can make that better. Maybe it's better if it's brighter. There we go. That's better. Think of similar triangles. You have a triangle right here on top. And then you have, if you continue this all the way down to the bottom, you have a very much larger triangle. Once you know the radius of the bottom one, you know the ratio of heights. Because they are similar triangles, you may be able to find the missing piece right over here. And that missing piece would be the radius of the cylinder. Once you have the radius of the cylinder, you've got everything you need. So those are my suggestions, my hints, everything that I can possibly do. I hope that this takes you through this section with flying colors. But if you have other questions, let me know. I can make a video. I can meet you on campus in person. I can meet you on Zoom. My goal is to support you as you continue learning these concepts. All right, off you go.